Welcome to the Explainer. Look, today we're not just writing code. We're going to build a fortress for it. We're diving deep into a really powerful concept that'll protect your software's core from the inside out.
So let me just start with this one big question. It's really what separates the good apps from the truly great, robust ones. What if your system could never, and I mean never, enter an invalid state? Not just, blocking bad data at the front door, but making it fundamentally impossible for it to even exist.
The difference between a system you can trust and, well, a total disaster, it often boils down to moments just like these. Look on the left, everything's fine, right? The data makes sense. But on the right, that's just complete nonsense. A negative order total, a negative age, that's the kind of stuff that just poisons your entire system, leading to crazy bugs, crashes, a total nightmare for data integrity. So how does this even happen? Well, it all comes down to one single core problem. We fail to stop our system state from getting corrupted in the first place. Let's dig into that. And honestly, the number one cause is surprisingly simple. We're trusting data from the outside world way too much. It's a classic mistake, right? We put a bouncer at the main entrance, our API, and we think, okay, we're safe. But what happens when another service sneaks in the back door, or a background job, or, hey, even a developer running a direct script? If you're only validating at the edge, you're leaving your system's core wide open.
So the solution here isn't just to hire more bouncers for the front door. Nope. We have to think like an architect. We have to build a fortress right around the core of our system. And this brings us to the main idea, domain validation. Now, this isn't just another checklist or another layer of if statements. It's a whole philosophy. It's about making your core domain layer the ultimate, non-negotiable guardian of its own correctness. Think of it like this. Your domain is a high-security vault, and the domain validation rules, they're the guards right at the vault door. This is a huge shift in thinking, you see. The validation isn't floating around somewhere else in your application. It's baked right into the domain model itself. Nothing invalid ever gets inside that vault. Doesn't matter where it came from.
Okay, let's break this down, because this is super important. On one hand, you've got stuff like data annotations or fluent validation. They live up at the API layer, and they're great for checking the format of the data. Is this technically an email address, or is this number in the right range? But domain validation, that answers a much, much deeper question. It asks, is this state fundamentally correct according to our core business rules? We're talking about business correctness, right inside the fortress.
All right, enough theory, let's get practical. How do we actually build the walls of this fortress? Well, there are a few key patterns that'll help us do just that.
We're going to look at three main patterns. First up, guard clauses. These are your simple, immediate checks. Then we've got value objects. Think of these as little armored boxes for your data. And finally, aggregate root validation, where the main boss of your domain, the aggregate root, makes sure any big changes are totally valid. First up, guard clauses. This is your absolute first line of defense. The motto here is fail fast, fail early. The second you try to create something with bad data, like a price that's 0 or less, bam, it throws an exception and stops everything dead in its tracks. No invalid state gets created. It's clean, it's fast, there's no confusion. Next up, we have value objects, and this is a really powerful idea. Instead of passing around, say, a plain old string that you hope is an email, you create an actual email object. The magic happens in the constructor. That's where the validation lives. If the code even runs, you are guaranteed to have a valid email. It's valid by its very type. Now you can pass that object all over your system with total confidence. So let's zoom out and look at the architectural flow. These patterns don't just exist on their own. They work together, creating these layers of trust, almost like a funnel that filters out all the junk before it ever has a chance to reach your precious domain core. So look, data comes in from the user. First, it hits the DTO validation layer. That checks the format. Is it the right shape? Cool. Then it might go to the service layer, which asks, does this whole workflow make sense? But then it hits the domain layer. And the domain layer? That's the truth. It asks the final, most important question. Is this state fundamentally valid according to my rules? It trusts no one. It revalidates everything. It is the final authority.
Okay, let's wrap this up. I want to hit you with a few quick questions to really lock in these ideas and get you thinking like a top-tier software architect. First question, what is an invariant? You're going to hear this term a lot in domain-driven design, and it's absolutely central to this whole conversation.
Simple. An invariant is a business rule that must always be true, no exceptions. Think of them as the laws of physics for your business. An order total can never be negative. A user must be 18 or older. These are your non-negotiables. And your domain's #1 job, protect these truths at all costs.
Okay, next question. What actually happens if you skip domain validation? What's the real-world cost?
The result is pretty much guaranteed. Invalid data will corrupt your system. It's not a question of if, it's a question of when. You end up with catastrophic bugs, you lose data integrity, and your system becomes fragile, unpredictable, basically a time bomb.
All right, last one, and this is probably the biggest takeaway. So, API validation just isn't enough? This is the most common trap developers fall into. Let's be crystal clear about this.
No, absolutely not. Trusting only your API validation is just plain unsafe. Why? Because data can come from anywhere. Other services, background jobs, a direct database script, you name it. Only the domain, the fortress itself, can guarantee safety. It has to be totally independent, a self-contained unit of pure business logic that protects itself.
And that really brings us to the core idea here. If you walk away with just one thing, let it be this. Domain validation ensures your business rules are always enforced, protecting your system from bad data no matter where that data comes from. This isn't just about writing tidier code. It's about building systems that are robust, reliable, and correct by their very design. So here's my final question for you. Now that your domain is a fortress, what are you going to build with that new level of confidence? When you know your core can't be corrupted, you're free. You're not fighting fires from bad data anymore. You're building skyscrapers on a foundation of solid rock. Thanks so much for watching.